Hi there and welcome to another network automation video. So in this video I'm going to take a look at using NAPALM with Ansible. So I'm going to go through the installation process. NAPALM is not included with Ansible by default, so you need to install it separately. And then I'm going to look at using NAPALM to gather some facts. So NAPALM provides structured data of a number of commands above and beyond what Ansible facts provide us. Also, NAPALM is an abstraction layer, so it allows us to manage with one framework a multi-vendor environment. So in my lab, I'm going to have Cisco devices and Arista EOS devices, and I'm going to show how using the NAPALM facts and what they call getters, the different commands it supports, that the returned data will look the exact same regardless of what the underlying vendor platform is that we're automating. And also NAPALM offers us the ability to manage these, to configure these multiple vendors, whether you're doing a merge or replace. It also supports doing diffs. And what we can do when we're using NAPALM is use this one framework rather than using the iOS underscore command or config for iOS devices, or the NXOS for Nexus devices, or using Juniper, Junos, and all of the other vendors. So with NAPALM, we can use one framework and it'll manage all of the vendors that we want to automate. The other feature that I really like of NAPALM is its testing framework called NAPALM Validate. So that allows us to test the state of our network. I'm not going to cover that in this video, but I will go over it in another video. But before we get on to the install, I just want to quickly show my lab. So this is a lab where my Cisco devices are CSRs, and Arista EOS devices allow me to have this multi-vendor network. But these devices require a lot more memory than the IOL devices that I have used in previous videos. Therefore, because my laptop has 16 gig of memory, I can't run all of the CSR devices. So I've shut some of these down, and I've shut down one of the Arista devices, but these remaining 3 devices that are up will be sufficient to demonstrate NAPALM to use the getters, as I said, and to do a configuration merge. So the first thing I'm going to do is install NAPALM. But firstly, I am going to be using Python virtual environments here, which is basically an isolated environment that allows me to install these different modules within that environment, and it doesn't affect the main OS. So if we just have a look at the pip list command here and do a grep for Ansible, we'll see that I don't have Ansible installed here. The other thing that's of note is that if you go into the Python interpreter using the Python command, you'll see that the default Python is 2.7, but that's not supported anymore. So most applications nowadays require Python 3. It is on this box. So if I do which Python, you'll see that Python 2 is user bin Python. But if you have a look at that directory, there's also a user bin Python 3. So when I create a virtual environment, I usually tell the virtual environment to use this version of Python, so that by default in my virtual environment it'll always use Python 3. So I'm in my home directory here at the moment, and I create all my virtual environments in a directory I created called venv. So if I just switch to that directory, you'll see that I already have a subdirectory called napalm-auto. So that's a previous environment that I've used to set up the playbooks in this video, but I'm gonna create a new one, and we use the virtual env command, and with the -p option I can tell it which version of Python I want to use. So Python 3, and then we give our virtual environment a name. So if we just call it venv-napalm, and it'll create that virtual environment for us. So if we want to then enter that virtual environment, we use the source command. But if I just show that, firstly, I've got this subdirectory created now. So if we just activate the virtual environment, it's in the bin and activate, you'll see that our prompt changes to venv-napalm. And if I do a pip list in here, you can see I've only got these 4 packages installed. Also, if I just go into the Python interpreter while I'm inside of the virtual environment, you'll see that it by default goes into Python 3 as intended with the -p option. So the first thing I'm going to do is I'm going to install Ansible. So pip install, I'm going to choose a particular version, so I just need to put it in quotes. So Ansible, I'm going to go with 2.9.10. And we just let that install. And once this installs, I'll do a pip list again, and we can verify that Ansible is in fact installed and the additional packages that it installs with it. So we'll just let this complete. If you do a pip list again, you'll see Ansible is installed version 2.9.10, and it's also installed some other packages like cryptography, Jinja2, etc. So now we need to install the napalm Ansible module. So napalm is not included by default with Ansible. You always have to install it separately. So we just install napalm Ansible. Forgot to install. So and the last thing we need to install is the napalm core module. So we just pip install napalm as well. Right, and if we do a pip list, we can see that we have lots of packages installed. So we should see napalm is there and napalm Ansible is there. So if we want to use napalm with Python, we have a couple of configurations that we must first complete. So if I just go into my home directory, Ansible, this is where I have my playbooks. The first thing we need to do is update our ansible.cfg. So I've just got the necessary config in here. So in the defaults option in the library, you'll see that I have to tell Ansible where the napalm Ansible modules are located, and you can see that it's in the virtual environment subdirectories that we created, but that is the previous one, so I need to update that now. So I need to change napalm auto to venv-napalm, and the same with the action plugins. So I just do the exact same again. Yeah, that's fine. And the other thing is the hosts file. So in the host file, I've got all my hosts in here, and I'm setting the network OS to be iOS or EOS, and I'm configuring the ports. So the Arista devices work off its API on port 443, and the iOS devices is just SSH. But you also need to tell Ansible the Python interpreter that you're installing, and this too is in my env napalm folder. And because I specified the -p option when I created my virtual environment, this Python here is actually Python 3. So that should suffice, and we can move on to our first playbook. So I've got this playbook, napalm get. There's a bunch of getters that napalm support. So if we just go to their website, and if you put in here getters, you'll see all of the getters that are supported and support matrix. So all of these commands here will return structured data, and this table here tells you where they're supported. So like we can see get BGP neighbors is supported on all of these devices, including EOS, Arista EOS and iOS, while some of them are not supported on all of the devices, but there's a good list of getters there that are supported. So one of them is get fax, which gives us fax similar to Ansible fax. So we're going to run that one, and another one is interfaces, and we'll run that and we'll compare the output of those two. So if I just go back here, I'll just minimize this. This playbook here, I'm running it off one iOS device and one Arista device, and I have two tasks. My first task is the napalm get fax task, and you tell it the host name is that host variable that we configured in the inventory file, the host file. Similarly, with username devOS is that Ansible underscore network OS and the password, and then the optional arguments we configure the port, which is 22 for iOS and 443 for the Arista API. And then in the filter, we specify that we want to get fax. I'm registering this to the napalm fax module, variable, and then with the debug module, I just print that fact. So let's just run that playbook. I forgot hosts. Okay, so that's running. It's a bit slow because, as I was saying, of the resources on my laptop. Okay, so it's run on the Arista and on the iOS device, and what we can see now is that with the get fax, this one here is for the Arista device. We can see the structure here: Ansible fax, napalm fax, a dictionary, fully qualified domain name, host name, interface list, etc. The information that napalm returns for the Arista device, the structure on the iOS device is identical. So if you're configuring your network and you want to loop through interfaces, you can use the same naming conventions regardless of the underlying vendor, which really simplifies your Jinja templates and your Ansible playbook versus using an EOS underscore command module and an iOS underscore command module to run a particular command or the config module or whatever. So that's a really good benefit of napalm. So if we just verify that further by having a look at one of the other commands, so I'll just change this to interfaces. We should see similar output. So I'll run this now again. So this time it's going to give us the show interfaces. So actually, did I not save that there? That's fax again. Oh, let me just correct that. So this time we've got the interfaces, and again you can see that the structure of the interfaces on the Arista devices is Ansible fax, napalm underscore interfaces, and then a list of our of each of our interfaces, which in each element of the list is a dictionary, and the iOS device, the structure is the exact same napalm interfaces and each of our interfaces. So that's the first benefit of NAPALM, but also it supports doing config merge, where it gets your config, merges it with the config on the device. It supports a config replace, where you give it an entire config and it just replaces it, ignores what's on there currently and replaces it. It also has a rollback feature, and it also has a diff, so we can configure diffs of our devices. So I've created a number of subdirectories in here. I've got a diffs directory and a configs directory. So any config that I generate using Jinja, I'll install in the configs directory, and I will tell Ansible to or NAPALM to take a diff, and that gets installed in my diffs directory. So if we just have a look firstly at the host files directory, where I have a simple data model to configure OSPF. So my OSPF dictionary sets the process ID, and it states what areas should be configured in each of the interfaces. So I'm just going to go with a single area 0 on each of the interfaces. So that's the iOS, and if we look at the EOS or the EOS, it's exactly the same. So I'm going to use that data model to create my configuration. So the way I've done that is in my templates folder, I've created a subdirectory, one for EOS devices and one for iOS devices. So if I go into the iOS devices, I have an OSPF Jinja file, and I loop through that OSPF interfaces dictionary here, which is a dictionary of lists, and I configure I go into the configuration mode for each interface, and I configure each interface to be OSPF point to point, so we don't have BDR, DR elections. And for the iOS device, I enable OSPF on the interface using the IP OSPF process number area number command. Slightly different on EOS. So on the EOS, you can't configure the point-to-point command on loopback interfaces. It's only relevant on Ethernet interfaces. So I have an additional check in here saying, if not loopback, configure the point-to-point command. So that means it doesn't go onto the loopback interface. And then when I configure the IP OSPF command, you don't specify the process, you only specify the area. So that's another difference. And finally, to globally enable OSPF, you do have to, in global configuration mode, configure router OSPF 10, like you would have traditionally in iOS as well. In the iOS device, that gets generated automatically when you configure the interface level command. And then because Arista is a switch, we have to enable IP routing, so I enable that there as well. So if we now go back to our actual playbook, napalm-merge.yaml. So what I'm doing here is slightly differently. I'm adding in iOS 1 here now, so we have 3 devices this time. I've centralized my credentials that I use for NAPALM as a global var. So if I had multiple NAPALM tasks here, I can just refer to all my credentials with one line now, rather than repeating this for each of them. So I just want to demonstrate how you do that. My first task is just the template module to create my configs using Jinja with the source command, and I tell it how to get to the templates subdirectory iOS or EOS by calling the Ansible _network OS variable that we configure in our inventory file, and our Jinja is ospf.j2. And the configuration that it generates, I store in my playbook directory, subdirectory configs with the format hostname of the device, inventory _hostname.conf. And then in order to do a napalm merge, I'm using the napalm install config module. The config file allows me to point to my configs directory for the configuration I want to apply. Replace underscore config false means I'm not going to do a config replace, which means I will be doing a config merge, or it enables a config merge if I choose to commit. Get diffs set to true, so I want to do a diff between what I intend to do and what is configured on the network, so I can verify it before I commit the changes. And then the commit changes is actually instructing NAPALM to perform the merge. So for the first run of this, I'm going to set this to false. I want to do a diff, and I'm saying store the diffs in my playbook directory, diffs subdirectory, with the format hostname.diff. So let's just run this firstly. Ansible playbook -i hosts napalm merge. This might take it could be quick this time. We'll just let it run. Yeah, so it's generated the config on the three devices, and now it's using the napalm merge. So it's log into the device, it does a diff. So I've deliberately left iOS 1 so that it would fail here, so that I can just demonstrate what's required. And Ansible will tell you here, or it's actually napalm, that in order to do a config with napalm, what it does is it takes your config file and it SCPs it to your device. So your device has to have SCP enabled. So if we go back to our lab and go into this device, let me just get rid of that. And if I enable IPSCP on here, so if I were to run this again, then it should be successful. So let's just run it again and make sure that we get a success in all three. So Gingy shouldn't change this time, and the napalm merge then should hopefully work on all three devices. So I'm not actually applying a config. I should just get a diff. So we can have a look at our diffs directory, and we have 3 files created. So if we just have a look at the iOS 1 diff, we can see that the plus indicates what it's going to configure. So on each of the interfaces, it's going to figure our 2 OSPF commands as we intended. If we compare that to our VEOS device, you can see that it's going to configure the point-to-point on our Ethernet interface, but only the area command on our loopback interface, and the area command doesn't have the process ID like on an iOS device. And it enables IP routing and then the router OSPF 10, and you can see also that it's going to enable the max LSA command, which is a default command. So what actually happens there is that it logs in, as I was saying, copies the file and does a diff locally on the file. I'm going to do another video where we can see exactly what's happening on the iOS device when that happens. So if we go back to our iOS device and we do a show run pipe section OSPF, you can see that OSPF wasn't actually configured. But if you have a look at the boot flash, you will see that there's a file in here called merge_conf, if we were to look at that, actually it's blank, it's blanked it out, but we will see when we run it the next time that config, that text file there will actually have our OSPF config. The other thing just on the Arista device is if you want to enable the API on the Arista device, it's done via the management API HTTP commands, and you just do a no shut on it. I've also put my management in a VRF, so I had to configure the VRF inside here as well, and no shut that. That's what enables the API. So if we go back to my playbook, go up a directory. So we've decided we're happy with the config that's generated. We now want to deploy it on the devices. So we just set the config changes option, save that, and rerun our playbook. So Ginger won't make a change. And our napalm merge should now push this config. It's still doing that diff. It will push the config, and that's the Arista device done. And we'll be able to verify the config is deployed. If we generated some config and we had a typo in it, like we misspelt OSPF and had it the wrong way around or something, what happens is that file gets SCP'd into the router, into its flash. It will do a diff and it will try and do the merge. The merge will fail, and it will then roll back to the config that it currently has. So it has that, napalm has that built-in auto rollback, which is a really nice feature. So if we go back here, we can see now on our device that we have neighbors up, which verifies that OSPF has been deployed on other two routers as well. So if we just do show run OSPF, we can see that OSPF is now configured, or it might be easier if I do it this way. You can see that OSPF is on our loopback interface and gig 1 interface as we intended. So we have a look at boot flash. This time we can see that there's a number of files in here, the merge config file. So if we do more boot flash, you can see that's the generated Ginger config that we SCP down to the device, and there's a rollback. So if we had a typo in here, and it would have automatically configured a rollback, and it would have just done a config replace on the device by copying the rollback to the running config. So you can see rollback.txt. You can see that is the config without the OSPF configured. So you have that comfort that if you do something wrong in your Ginger template, it will actually auto roll back. So we'll just quickly go into the Arista as well, just to show that it's done it on multi-vendor environment. So there's our IP routing enabled. Interface loopback 0 is enabled in area 0 of OSPF. Our Ethernet 1 is configured as network type point to point and area 0, and also we have router OSPF 10. So that is my video on using napalm to get facts, and also to do a napalm merge across multiple vendors with one simple playbook, not using multiple Ansible modules, which is really nice. The last thing I just wanted to put up on the screen is the steps that I used to install the virtual environment. There was quite a number of steps. I've also included here the installation of the virtual env itself. I didn't need to do it on my Ubuntu, I already had it. So if you want to install virtual env, it's simply pip install. I created a directory venv, which was already created before this video, and I cd into that directory. Virtual env with the -p option to specify Python 3 as the default and create my venv-napalm virtual environment. I activate the virtual environment. I install Ansible 2.9.10 in this instance, install napalm-ansible and napalm core. Then I configured my ansible.cfg file to update the library and action plugins parameter. And finally, in my config Ansible directory, I had to ensure that the Ansible Network OS is configured, that the port is configured, which is required for Arista, and that the Ansible interpreter is configured. And that concludes this video. The next video I'm going to continue on napalm, and we look at napalm a bit closer. Thank you.